Hello, my name is Gabrielle Stein, and this is Week 3 Chem 182 Lab, The Quest for Crystals. The objective of this lab was to investigate the process of crystal formation. Specifically, we analyzed the formation of alum crystals. Alum is used in pickling pickles and apparently making pulled pork very crispy, as well as other uses. We achieved our alum crystals through a series of steps. In the first step, we are given approximately 1 gram of aluminum foil. This aluminum foil is dissolved in potassium hydroxide. This reaction forms aluminum hydroxide and hydrogen gas. The hydrogen gas is apparent in the bubbling around the aluminum foil. Because the materials used were not entirely pure, the solid impurities were formed and were then filtered out using a Buchner funnel. The second step is adding 25 milliliters of sulfuric acid, which causes the aluminum hydroxide to precipitate out. Then, another 25 milliliters of sulfuric acid was added, which was meant to neutralize the hydroxide and allow it to dissolve into the solution. Initially, the solution with 50 milliliters of sulfuric acid did not dissolve all of the hydroxide. Therefore, the solution was heated on a hot plate until the solution was clear and colorless. This signified that all the hydroxide was dissolved. This worked because the increase in temperature of the solution increased the solubility because the molecules gained more kinetic energy and therefore could break apart the intermolecular attractions between molecules of the solute. The resulting solution had potassium, aluminum, and sulfate ions, which are the reagents for the creation of alum. The alum was then placed in an ice bath, which lowered the temperature of the system and therefore lowered the kinetic energy. This shifted the system out of equilibrium, causing the solid alum crystals to form. These alum crystals were then filtered out and were a fine white powder. Using the chart of solubility guidelines, we determined how much alum would completely saturate the solution. We then added slightly more in order to ensure that it was. This solution was then placed in 2 vials to be taken home with me and my lab partner and observed. I will discuss the observations of these vials later on in the video. Stay tuned. Now let's talk about different ways to create crystals. There are several different methods to forming crystals. The first method is similar to the method we used in our alum project, in which we use slow evaporation. In this method, you add solute to the point of saturation and then let water slowly evaporate over the course of several days or weeks. As water evaporates, the concentration of the solute increases to a point where it is too much to stay dissolved in the solution and then becomes crystals. However, in order for anything to become a crystal, the process of nucleation has to occur. Nucleation is the initial process in the formation of a crystal. In nucleation, a small number of ions, atoms, or molecules become arranged in a pattern characteristic of a crystalline solid. This becomes a site upon which additional particles are deposited, and therefore the crystal grows. This is why it is important when we take the vials home to disturb them as little as possible. If the vials are disturbed, the nucleation sites are disrupted, and this causes crystal defects or dislocations in which the crystals do not form properly and are disordered. Another method is called slow cooling. In this method, the solution is heated to its boiling point and a solute is added to the point of saturation. In the end, it is transferred to a heat bath or allowed to reach room temperature slowly. As this happens, the crystals begin to form as the temperature drops. This is what would happen if we were to make salt crystals using NaCl. In order to make sodium chloride crystals, we would boil water and then add salt to the point where it was saturated. We would know this because as we added the salt, no more salt would dissolve and it would sink to the bottom. The solution would then be let to cool, and as the solution slowly cooled, the crystals would form as the solute precipitates. Sometimes a string or other object is added to the solution. This serves the purpose of creating a place for nucleation sites to form, although sometimes this does not create the most effective crystals. The next way of forming a crystal is called a binary solvent system. In this method, a solute, solvent, and precipitant are used. The solute is the molecule that the crystal will be formed from. The solvent is the liquid that the solute can be dissolved into, and the precipitant is the liquid that the solute is insoluble in. The way this method works is the solute is dissolved in the solvent, and then the two liquids are mixed together. It is important that the liquids are of different densities, so one travels to the bottom and the other to the top. Through diffusion, the liquids mix, and the crystal forms as the soluble and insoluble properties of both liquids combine. The binary solvent system can also be used in a process called vapor diffusion. In vapor diffusion, the solute is dissolved in the solvent, which has a higher boiling point than the precipitant, which is insoluble. In this case, the more volatile precipitant diffuses through the solvent, and this leads to oversaturation, then nucleation, and then crystallization. This method is important because it can produce very good crystals with few nucleation sites that can be used in science. Okay, so that was a lot of chemistry, and now we're going to talk about our individual crystal vials. Unfortunately, we have no crystals. This could be due to several factors. A, time. There just hasn't been enough time to allow enough water to evaporate. B, we might have knocked it over. Oops. C, we're just cursed. In any case, the solution is still clear and colorless with no crystals forming. However, this does not mean that there are no crystals present in the solution. This just means that the crystals at this point are too small for the eye to see. We hope to see crystals forming in the next couple of days, and you bet you'll see them in our next video. Thanks for listening to this 8-minute video about chemistry. Oh wait, there's more. I'd like to thank my sources. The MIT Department of Chemistry X-ray diffraction facility for their enlightening article about growing quality crystals. Chemistry.about.com for their very informative article about how to grow table salt or sodium chloride crystals. Would recommend. And finally, Encyclopedia Britannica for their amazing article about nucleation and crystallography, a New York bestseller. That's all. Bye.